Hello everyone, thank you for joining me. My name is John Sand. I'm a mold flow engineer in the automotive industry. Today I would like to go over my process flow for going from customer CAD to reverse warped or Kentucky winded CAD and creating a cavity block based off that model. So first, where do we get the reversed warped data from? Well, you're going to run a study. In this case I have a mold flow study. We are going to go to our deflections all plot. We're going to hit results, export and publish, warp shape, and from here I always select CAD file. Here you can choose the actual warp or opposite. You can scale it. And from there you can choose general CAD, SAT, or step file. I typically choose step file. I have all that saved. So once you have that data, we come into Cimatron, and here I have, just for comparison, our actual warp from mold flow in red. I have our customer CAD planar part in green, and I have our reverse warped model in orange. I also have our original model scaled up to match what mold flow predicted. And we might ask ourselves, well, why we have a model from mold flow, why don't we just use this? And the reason is undercuts. So if we, or die lock condition. So if we go to a draft analysis, you'll find most of it looks pretty good. But when you get into areas like the holes, you'll see half the hole is not die locked and half the hole is. And then you get into little pockets, and you can see we have negative draft. So essentially this plastic is trapped in there from the steel, by the steel. And we also have two other pull directions, not just the Z or the opening direction. We also have these little connector faces that are all die locked, and our tabs could have some die lock as well. Let's try to get a better direction. I've got some negative draft there. So the model as is not very useful, but we can still get a lot of data out of it. So what we are going to do is create a point cloud on the skin of the mold flow reverse warp. So we'll go to solid, come down to warp, create points on skin. Now from here we can do the entire model, or we can just pick faces and do individual faces. That's very useful if there's details that, especially that have critical dimensions on the print. That's very useful for stuff like that. We can also change how many points we have by increasing or decreasing the distance between points, minimum curvature, and we can ignore vertical walls or include them. I usually ignore them at the beginning. I think it gives the advanced warp function a little more wiggle room to move the part. You can always come back and make more point clouds, add more points, things like that later. Probably should pick the part first, or the faces. And this is going to generate a point cloud of the reverse warp part from mold flow. The more points you create, the longer this will take. Okay, and you're going to get something that looks like this. Like I said, you can change, you can add vertical walls, you can add more points. I have that kind of standard point cloud there, a more detailed one here. Really capture a lot of those features, and it will allow me to push them around with more accuracy later. So once we have those point clouds, then we're going to turn off our mold flow reverse warp, and we're going to turn on our original scaled. We're going to come up to solid, down to warp, and we're going to match those points to the skin of our scaled planar model. Now here we want to match our minimum curvature, and we want to save pairs to a CSV file. I already have a bunch of these saved, so we can turn off or delete our point clouds, and then we come back up to solid, warped, advanced warp. We're going to pick our part. This second option here will allow you to fix faces and add extra points to really cement them in. I think in the beginning it's good just to leave them all where they are and see what we get in our first warp. This third box here, you can you can pick the warping direction. This is going to be your opening direction typically, and you can choose to keep or remove the original. I choose to remove it since we are using our reverse warp as our guide. A couple other options. Define offset constraints. These are points, so I can click on these points and tell them they can only move in certain directions, certain distances. 2D constraints, I can pick edges, curves, things like that. We're going to leave all that alone for now. And we're going to this last option. It's usually the defaults to none by table, and the spring back points dialog box pops up. We're going to open our pairs files. I've created many of these. I do want to go over some of the issues we can see. So you're going to load your point cloud. Come on. And sometimes these points, when they match to the from one to the other, some of the faces of the points will be too close to an edge and will jump to another face. And so in this dialog box, we want to do same side. You're going to calculate your points, and then we're going to be able to use these guys to kind of show us where we're at. And so the yellow is your source, the red is your target. When I say bad points, like, you can get a couple different things. Let's see if we can find one on an edge. See, I told it in the beginning to ignore vertical walls, and yet it seems to be jumping to this vertical wall, and it was supposed to jump to the bottom surface. So points like that, you can just grab it. They can cause twisting and distortion, so I just try to delete them out. You just highlight the point or points, delete point, goes away. Yep, there it goes. And you can also find points like this. Now, for some reason, this point jumped all the way to the bottom surface. Now, that's going to cause quite a bit of distortion, so that I'm going to delete as well. So this is one thing you can do. You can also manipulate these points by changing scale factors and things like that, but I'll get into that in a minute. you can also make point clouds of multiple faces, match each one of those point clouds to a pair, so you'll have a bunch of individual pairs, and then you can add them individually, or we can just replace them. In this case, I'm just going to replace it. I just wanted to demonstrate the bad points. Just something to look out for. And the more points you have, the more of those wonky vectors you can have. And those will cause you a lot of headaches during the warp phase. So, something to think about. Oh, my computer's struggling today. Okay, we're already same side. Okay. So from here we can just preview it, make sure our reverse warp is on so we can kind of see what happens. Hit preview and see what it does. Sometimes you'll get lucky and the points alone will be enough. Sometimes you'll have to add extra constraints. Sometimes you'll have to select edges and curves. This doesn't look too bad, but I mean, we got a lot of tiger striping and bleed through, but we do have edges that have deviated. So what we can do there, we can go back up to coincident constraints. I can say, I can now pick curves, right? I have my point cloud, and my pairs, all that's in there. So now let's try some curves. So you always start with your source and move to your target, which is going to be a reverse warp. So essentially you're always picking this green part first, otherwise it'll think that's your target. So source, target, you kind of got to keep that in your mind, because if you do that backwards, it'll try to warp them together backwards. So just pick a couple lines. Let's see what it does. You don't want to pick 5-10 lines and then preview it, otherwise if it fails on you, you won't be sure which one caused the failure. And sometimes it can just be one curve. So see how it pulled those together? So combining the points and the curves can be really effective, and you're going to have to go around the edge of the part. I would typically pick edges and curves that are on call outs on the print that need to be flat, or a mating surface, and you're going to do that all the way around the part for as many features as you have to get this to match as closely as you can to Moldflow's prediction or whatever analysis you're using. And so once you complete that, what you will have is a part that's been warped. Now this one's been warped with points only, so I didn't use any curves. You can see my edges aren't lined up. I do have bleed through. A lot of the surfaces are right, but my edges are wrong. But just to demonstrate what Cimatron does here, so if I turn off my Moldflow and I do a draft analysis, this part's been warped. Now all these are zero draft. All my holes and pockets are where they should be. These ones are in red because they're coming out of the bottom. Okay, check the bottom. We look underneath here, everything looks good. So that's what this is doing, is keeping our draft positive while warping the part. Now we still have a couple issues here. Obviously, just with the points weren't enough. But you're going to have these extra pull directions, right? Our connector faces and our little tab windows down here. But let's look at what happens if we add points and edges. Or just, I got edges only here. Did a pretty good job with the holes, and all of our edges line up nice, but the top and bottom can be a little wonky. But overall, this isn't bad. So if we go to points and edges, a lot of bleed through, all my holes line up. Just with the normal points though, without any scaling of any of the points, I still have some issues. Right? These little bosses didn't line up. I would like to see my tabs pushed out. I think I did scale these tabs a little bit, but I'd like to see them pushed out a little bit more. That's just based on my experience with tabs. So what I ended up doing was I added more refined points to get these lined up, and I had to scale those points. So if I go back into my advanced warp, and you look at the table of the points I had before, you can highlight groups of points or single points, and you can scale them. So I think some of these are scaled at 2.5, some of them are scaled at 1 1/4. It's just whatever you need it to be. You definitely need a high-powered computer. So if I scroll down here, let's see. Oh. So many points. Oh, here we go. I saw some 2s. 2.5s. So, highlight your points. I can just grab some, highlights them, and then I can change the scale factor and recalculate just for the selected. So that's a real nifty tool to force it if it doesn't want to work with you on the regular 1 scale. Now, I might go back into this wall. So I back out of here. This wall didn't get pushed as far as I would have liked it to. So I think if this was a production part, I would absolutely go back in there and clean that up. And just like the others, even with the scales, we still have positive draft. Everything looks good. Our little bosses that we pushed over, everything looks good. However, we still have a couple problems we got to deal with. The warp function can only keep the draft positive in one direction. In this case, it's a Z. So we still have to fix these connector faces, and we still have to fix our little windows. So in the next video, I will be covering how to do extra pull directions. So thank you for joining me with the Cimatron Advanced Warp Function. I look forward to seeing you all in the next video. Thank you and have a blessed day.